Okay, in our previous video I showed you how to integrate a power of sine times a power of cosine where at least one of the two exponents was odd. And now I'd like to focus on the case where both of the exponents are even. So in this case we're going to need the so-called half-angle formula, which I provided right here. And just to give you a nice example, why don't we pick both of the exponents to be 2. So what we have to do is we need to rewrite both of our trig functions as a square raised to a power. Now since both of these exponents are 2, this is sine squared to the first. Had it been sine to the fourth, I would need to rewrite this as sine squared squared, and had this been cosine to the sixth, I would write it as cosine squared to the third. This is the simplest example of this, so we'll work on this one first. So what we do, after we've rewritten them in terms of sine squared and cosine squared, we'll substitute in these half-angle formulas everywhere we see either sine squared or cosine squared. Well, that's all we see here, so I'm going to replace sine squared with this and cosine squared with that. So what do we get? We get 1/2 times 1 minus cosine of 2x times 1/2 times 1 plus cosine of 2x dx. Now, I'm going to multiply all this stuff out and simplify as much as possible before I try to do the integration. These two constants, 1/2, can be grouped together as a fourth. That's a constant multiple, and constant multiples can be brought out in front. And now, 1 minus cosine 2x times 1 plus cosine 2x is the factored form of the difference of squares. If I multiply that out, I should get 1 squared minus cosine of 2x squared, which would be 1 minus cosine squared of 2x. And now, we see that we can integrate 1. Here I have a trig function raised to an even power. Our system for dealing with this is, once again, to use the half-angle formulas. So I need to rewrite cosine squared of 2x using the half-angle formulas, and this formula does not directly apply as it's written. I don't have x, I have 2x. So what I'm going to do to show you how to deal with that is I'm going to rewrite this in a slightly different format. Just to prove a point, I'm going to replace the x with a u, same formula. U. And I would like to know how to use this formula when u is 2x. So if u is equal to 2x, this becomes cosine squared of 2x, which is what I have, equals 1/2 times 1 plus, oh boy, that should be a 2u, 1 plus cosine of 2u. 2u is 4x. So this is the correct expression for cosine squared of 2x, and that's what I'm going to put in here. So what does my integral become? I have 1/4 times the integral of 1 minus this, 1/2 times 1 plus cosine 4x. Now, once again, it would be nice if we simplified this first, so let's go ahead and multiply things out as appropriate. 1 minus 1/2 minus 1/2 cosine of 4x. 1 minus 1/2 can be combined into 1/2. And now we've got something we should be able to integrate one term at a time. So 1/4 times antiderivative of 1/2 is 1/2x minus 1/2 times the antiderivative of cosine of 4x. Now technically here we're doing a u substitution, letting u equal 4x. It's easier if you'll just treat this as a chain rule, kind of opposite of a chain rule, whereas if you were to take the derivative, you'd multiply by 4. Taking the antiderivative, you need to divide by 4. So that's where the times 1/4 is coming from. I'm dividing by the derivative of 4x. And then the antiderivative of cosine is plus sign. And then one can always check this by taking the derivative with the chain rule, if you're not comfortable with that step. And then to finish it off, I'll go ahead and multiply through by the fourth and combine any like terms I have. 4 times a half, that's an 8th x. That's an 1/8 times a 4th, which would be minus 1 over 32, sine 4x.